In this video, we're going to explore the use of a steel rule for measurements and have some practice examples as preparation for the measurement job performance station of the mechanic certification. From Mechanic Station 4, three different measurement tools are used, including the steel rule, the digital caliper, and the digital micrometer. This practice and video is to focus on the steel rule measurements. Keep in mind, the steel rule can vary from manufacturer to manufacturer based on how the exact markings are laid out or identified on the scale. Here are just a few images of different scales, all with either 32nd inch or 64th inch scales used. These are the two scales that we're going to explore. Steel rule measurements can come in various scales. This could be an 1/8 inch scale, in other words, 8 divisions per inch, 16th scale, 16 divisions per inch, of which most tape measures used for constructions utilize one of those two sizes. You may also find 32nd inch scales, 64th inch scales, 100th scale, and so on. The scale identifies the number of divisions present per inch, with the higher number indicating a greater number of divisions and correspondingly a smaller increment of measure. This practice will focus on both the 32nd inch and 64th inch measurement devices. The markings typically vary in length based on the number of increments. In this case, we will see 2 divisions highlighted in blue, and then each of those divided again, creating 4 divisions, and then 8 divisions, 16 divisions, 32 divisions, and finally on the scale on the right, 64 divisions. Marks are sometimes labeled on the scales to aid in the measurements. Each set of marks then identify the number of divisions. For example, 1/2 inch marks, 1/4 inch marks, 1/8 inch marks, 16th inch marks, 32nd inch marks, and again on the right scale, 64th inch marks. Here are 2 examples that we will look at, one measurement each using both the 32nd inch scale and the 64th inch scale. How long is the figure shown? With our 0 set at the edge of the measured device, we find that the line that is closest to the thickness or the length of the item, in this case, we see that the line of the scale that matches exactly with the edge of the item we are measuring. In this case, we are at the 26th line, which can be recorded as 26/32 or 13/16 if we are reducing the fraction. Now let's take a look at the same part, but using the 64th inch scale for measurement. Again, we find which line is the closest to the edge of the item being measured. And in this case, we are at the 52nd line, which can then be read as 52/64, 26/32, or 13/16, keeping in mind that both the 13/16 and 26/32 are just reduced fractions of the same value that is aligned with the 52nd line, or 57/64 of an inch. So what is the purpose of having different scales? The smaller the size of the increment, or the greater the number of division, yields the greater accuracy in the measurement. In this example, we're going to measure an item that falls in between the measurements of the 1/32 inch scale. How long is this item? It can be seen that the item falls somewhere between the 26th and 27th line, which could be measured as between 26/32 and 27/32. But at the same time, we could estimate the position between the values known, which would be perhaps at the 26.5 line. If we take the values and multiply by 2, we get 52 and 54, which would be equivalent between 52 64ths and 54 64ths, which ultimately corresponds to 53 64ths. So if we look at the same item using the 64th inch scale, we see that the item now lines up with the 53rd line, which would in fact be 53 64ths. If we then overlap the scales, you will see that the measurements are identical, with the 64th scale having each of the 30-second increments divided again in half, giving the 64 increment measurements. Here we will allow for some practice of measurements. There are 4 different parts to measure, with 2 each being used on the 1/32 inch scale and 2 on the 1/64 inch scale. We will now allow some time to make your measurements, and we will then take a look at the solution for each. Now let's look at the solutions. For number 1, or the top left, we see that the part measures to the 27th line, which would be measured as 27 30-seconds. For number 2, the bottom left, we see that the part measures to the 60th line, which would be measured as 60 64ths, or could be reduced to 30 30-seconds, or 15 16ths if we are using reduced fractions. For the third, we see that the part measures to the 16th line, which would be measured as 16 30-seconds, or could be reduced to 1/2 of an inch. For the fourth one, we see that the part measures to the 28th line, which would be measured as 28 64ths, or could be reduced to 14 30-seconds or 7/16, depending on the level reduction of the fraction. Here we will look at 4 additional practice problems. Again, there are 4 different parts to measure, with 2 each using the 1/32 inch scale and 2 using the 1/64 inch scale. We will allow for some time to take your measurements, and then we will look at the solutions for each. Now let's take a look at the solutions. For number 1, we see that the part measures to the 8th line, which would be measured as 8 30-seconds, or could be reduced to 1/4 of an inch. For number 2, we see that the part measures to the 18th line, which would be measured as 18 64ths, or could be reduced to 9 30-seconds. For number 3, we see that the part measures to the 6th line, which would be measured as 6 30-seconds, or could be reduced to 3/16. For number 4, we see that the part measures to the 22nd line, which would be measured as 22 64ths, or could be reduced to 11 30-seconds, again if we are looking for reduced fractions.